Now that we have reviewed slope, let's graph linear equations by using the slope and y-intercept. We will find the slope and y-intercept of any given equation and use it to graph it. We must first find the slope-intercept form of our equation to use the method. The slope-intercept form of an equation looks like this. It has to be placed into y equals mx plus b. Once you have your equation looking like y equals mx plus b, then we can find the slope because m will be the slope, the coefficient of x, this number in front of x will become the slope, and then the y-intercept will be this b, the one that is alone without the x's. Alright, so then to do example 4, we're going to use the same equation as example 1 and 2 just to show that with this method we obtain the same graph all over again. So then I have 3x plus 2y equals to 6. The first thing we have to do is solve for y so that we can place it in the form y equals mx plus b. So let me bring my equation and start the work. So 3x plus 2y is equal to 6. Now in the equation, notice how the x's are on the right side of the equal sign. And right now the x's are on the left side of the equal sign. So then the first thing I'm going to do is move those x's to the right side. Because the x's is a positive 3x, I'm going to subtract 3x from both sides of the equal sign. So 3x minus 3x, that's going to go to 0, leaving me with 2y only on the left side. Now on the right side, these two are not like terms. I cannot combine them because one has an x and the other one doesn't. So I'm going to have to write them separately. The one that I write first does not matter, but if we want to match this form, I'm going to write the x's first and then the 6 second. So this is minus 3x, I write it, and then I have a 6. Now just to distinguish between the x's and that 6, since 6 is positive, I'm going to put a plus right in front. Now we're not done. You notice how in this form the y is by itself. There are no numbers or pluses or minus around it. So that means that for this one, I have to remove that coefficient of 2. So the way we do that is by dividing every single term by 2. What you do to the left, we must do to the right. So 2 divided by 2 will be 1y, or just y. On the right side, 3 cannot be divided by 2 evenly, so I'm going to leave it as a fraction. So this is negative 3 over 2x. And then I have 6 divided by 2. Well, 6 divided by 2 can be divided evenly. That is just 3. So we look, is this already in this form? And it is. I have solved for y, then I have x's, and then I have b's. Here's my y, these are my x's, and then my b. Now to distinguish between these two, since 3 was positive, I'm going to place that plus. What does that mean for us? That we've completed step 1. Now I need to complete step 2. I need to find my slope and my y-intercept. I need to find m and b. Now the slope is that coefficient of x, that number in front of x, and only the number. So then the slope will be negative 3 over 2. The b is that number that is on its own without any x's. So then the b for us will be 3. Okay, we've completed step 2. We found m and b. Now we need to use them to graph. The way that we graph these, we always plot b first. The y-intercept always gets plotted first. So the y-intercept is 3. That means that this graph is going to pass the y-axis at 3. 3 up. Here it is. This is my y-intercept at 3. Okay? Once you plotted that point, then we're going to use the slope. I'm going to use the slope to find the next point. So this one is done second. Now, how do we deduce the slope? Well, remember that the top of the slope is considered the rise, and the bottom of the slope is called the run. But this one is the negative. Now, it doesn't really matter who you give the negative. I'm going to give the negative to the number at the top. That means that I have a rise of -3 and a run of 2. So if I have a rise of -3, that means that I'm going to go 3 down. 1, 2, 3. And then a run of 2 positive, I'm going to move 2 to the right. And this is where I plot the next point when I give the negative to the numerator. What happens if instead of giving that negative to the top, I give the negative to the bottom? What if I give the negative to the denominator? What if I give it to the run? Well, that means that the rise will be 3, positive 3. So I'm going to go 1, 2, 3 up, and then the run is -2. That means that I'm going to move 1, 2 to the left. This is where I plot the other point. It doesn't matter which one you use. If you give the negative to the numerator or the negative to the denominator, because you're going to see here when we graph these points, they create the same line. All 3 points line up nicely. So that means if you have a negative slope, you can either give the negative to the numerator or the negative to the denominator. It doesn't really matter because they give you that same line. They all line up in the same line. And this is the same result as we got in example 1 and in example 2. You just have to make sure that whenever you use the slope-intercept form, that you always plot the y-intercept first and then use the slope to find the next point. But what if you don't want to solve for y because you have difficulty solving for y? Well, this is not the only way that we can find the slope in the y-intercept. Let's do another example so that we can see how else can I find the slope in the y-intercept and continue to use this method. If we don't want to solve for y, we can still find the slope in the y-intercept using the following formulas. So if your equation is in this form, that you have the ax and the by on the left side equal to a c, to a number, then the slope can be found by using -a/b, and the y-intercept can be found by dividing c/b. So in our example 5, we use the same equation as before. We have 3x plus 2y equals 6. Let's see if it's in standard form. I'm going to bring down ax plus by is equal to c. We bring down our equation, 3x plus 2y is equal to 6. And I notice that my equation is in standard form, where a is 3, b is 2, and c is 6. Then using these formulas, I can find the slope by doing -a/b, and I can find the y-intercept by doing c/b. So let's plug in. This will become -a, well, a is 3, over b, which is 2, and b becomes c/b. So that will be 6 divided by 2. Now I cannot simplify 3 by 2 evenly, but since they have different signs, this is -3/2, and b, I am able to simplify. 6 divided by 2 is 3. And if you notice, we get the same slope and the same y-intercept as we did before. Remember, first we plot our y-intercept, which is 3, and then we do our slope, and it doesn't matter who you give the negative to. So I'm going to give the negative to the numerator. So if it's -3, that means that I'm going to go 3 down from the y-intercept. That's 1, 2, and 3, and then I'm going to move 2 to the right. So that is 1 and 2, and that's where I plot my point. And once I have 2 points, I can easily draw my graph. It is the same result as the ones before. Now, one drawback that this method has, regardless if you use the standard form to find the slope and the y-intercept, or you use the slope-intercept form to find the slope and the y-intercept, is that b could result being a fraction. We will find it difficult to graph since we will have to approximate where that b is located.
Thank you so much for watching, and I'll see you in the next one.